So this is a continuation on the quadratic formula. We never actually used the quadratic formula in the last lecture. We only talked about why we need the quadratic formula and just big picture on how to solve quadratics. So make sure you've seen that lecture before you watch this one, because that is a really crucial concept in chapter 4. So as we mentioned in the last lecture, this is going to be the method by which we can solve any quadratic. It is this formula here. It is quite long, but it's super nice because this always works. If you're ever stuck, just be like, I got the quadratic formula, that's what I'm going to use. The quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c, and all of that is being divided by 2a. That will give you the x values. It's going to give you 2, right, because of the plus or minus. So it's going to give you both solutions to this quadratic that you weren't able to solve using one of the other methods. I have some steps here for us. In order for the quadratic formula to use, one side has to be set equal to 0. So step 1, set one side equal to 0. Step 2, identify your a, b, and c. Remember, quadratics are written as ax squared plus bx plus c. So whatever is in front of the x squared is a, whatever in front of the x is b, and whatever is by itself without an x is c. You are going to simplify underneath the radical first. Simplify all of this stuff. Remember PEMDAS. And then simplify that radical, if you can, using the stuff from section 4.5. Then you are going to get rid of both of the plus or minus by creating 2 different problems and looking to simplify the numerator and denominator from there. So let's go ahead and take a look at just a few examples. Here's our first example here, 3x squared plus 5x minus 8. So if we are using the quadratic formula here, of course, the a term is 3, the b term is 5, and the c term is negative 8. One side set equal to 0. We have to make sure we have that. Then we would identify a, b, and c. We've done that. We know that the b term is negative 5, so we'd take this out. We could put a negative 5 there. Get rid of this, put a 5 in there, 5 squared minus 4, a goes there, negative 8 would go there, and 3 would go there, right? We're just kind of plugging stuff in. Our next step is to solve underneath the square root side. And for those of you with graphing calculators, as you guys all should, you should be able to, don't type in the root, but do negative 5 plus or minus, and you should be able to type all of this that's underneath the root into your calculator and write that number here. So I don't have my calculator in front of me at the moment. So 5 squared is 25 minus 3 times negative 8 is negative 24. And negative 4 times negative 24 would be 96. And then 25 plus 96 would be 121. Okay, so negative 5 plus or minus 121 over 6. Now, remember, what you should have been able to do, and I would hope that you tested this, is don't type in the root, but just type everything underneath the root into your calculator, and then write that number underneath the root. So from here, you would try to simplify the actual radical if you could, and actually 121 is a perfect square. So we would have negative 5 plus or minus the square root of 121 actually is a number. If you type that in your calculator, you'll just get 11 over 6. From here, you would break this into 2 problems. One of them would be negative 5 plus 11 over 6, and the other would be negative 5 minus 11 over 6. Add your numerators first. Negative 5 plus 11 is positive 6, and positive 6 over 6 is 1. And then negative 5 minus negative 11 is negative 16, and negative 16 over 6 would be negative 8/3. Those are both of your answers, and that was using the quadratic formula. So that was a fairly straightforward example. What made it straightforward was that this was a perfect square. 121, you can actually take the square root of 121. That's not always going to be the case, obviously. There will be more difficult problems, but this is a fairly straightforward quadratic formula example. Let's look at another one. So step 1, here's our quadratic. 2x squared minus 7 is equal to x. Step 1 says to set one side equal to 0. Currently, it's equal to x. So we have to move this x to the other side. We can do that by subtracting x. So we'd have 2x squared minus x minus 7 is equal to 0 once we move that x over. Let's go ahead and try to use the quadratic formula here then. We know that our a term is 2, our b term is -1, and our c term is -7, right? A, thing in front of x squared. B, the number in front of x, and c is the number by itself. Our quadratic formula is -b plus or minus the square root of b squared minus 4ac over 2a. So we're just going to start plugging this stuff in. And remember, when you plug stuff in, put parentheses around it. So -b, negative, you could write this as -1. You don't actually need the parentheses in this particular problem because it would have given you the same thing. Where you need it is if you have an exponent there. So that one would absolutely need it. So when you substitute -1 in there, it has to have those. That's one of the main things I take points off for in the quadratic formula, is when you substitute a number in with that has an exponent on it, always put that number in parentheses. Minus 4 times 2 times -7 all over 2 times 2. All right. That's just me substituting it into the quadratic formula. Now what I told you guys is to just take everything that's underneath the square root sign, and you should be able to type that into your calculator. Don't type in square root sign, just leave that as like this, but type all of that into your calculator. I should be able to do this math. -1 squared is actually +1. And when I multiply all of these things, -4 times 2 is -8, and -8 times -7 would be 56. So you guys should have gotten 57 if you typed that in your calculator. 2 times 2, of course, is 4, and -1 would be +1. So from here, you would look to simplify underneath your root. And remember, the way that you simplify square roots is you think of the perfect square factors. 1, 4, 9, 16, 25, so on and so forth. And you see if any of these numbers are factors of 57. And, you know, this goes on forever. The next one would be 36. But none of these numbers are factors of 57, other than 1. And so this is a simplified root. Therefore, the answer to this question is just going to be 1/4 plus root 57 over 4, as well as 1/4 minus the square root of 57 over 4. Those are your two answers to this question. 1/4 plus root 57 over 4, and 1/4 minus root 57 over 4. So in this problem, the a term is 3, the b term is -5, and the c term is 1. We're going to go ahead and use the quadratic formula. We're going to plug in -5 for b. That would give us 5 plus or minus the square root of -5 squared minus 4 times 3 times 1 all over 2 times 3. Remember what I told you guys to type this into your calculator without the root sign. So it'll be 5 plus or minus the square root of whatever you get out when you type that in. If you type that in, -5 squared minus 4 times 3 times 1, you would get 13 over 6. The square root of 13 cannot be simplified. There's no perfect square factors that are of 13, so it would just be 5 6 plus root 13 over 6 is one of your solutions, and 5 6 minus root 13 over 6 would be the other solution. If you wrote it like this, that would be fine as well. So that's all I have for you guys for this lecture of section 4.8. Please let me know if you have any questions.